Hello guys, so we are here today to solve our challenge problem for the day. Today's challenge is 132 pattern. So you see 3 is greater than 1 and 3 is greater than 2. So the greatest number is in the middle, and on the left is the smallest number. On the right is the number which is in between 3 and 1. So middle is the peak, and smaller to the peak is on the right side and the smallest is on the left side. So this is the pattern, and we are given an array and we have to find out whether there is a subsequence. So subsequence and subarray is two different things. So subarray is contiguous, but subsequence need not be contiguous. With this in mind, we will try to find whether this 132 pattern is there in this array or not. So the simplest thing which comes to my mind is, I start like this. For int I is equal to, we'll start from 0, I less than nums dot length. Okay, so I can go, yeah, it will go till -2 plus 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 I. Okay, and then for int j is equal to I j k, k I j I j is equal to I plus 1, and j is less than nums dot length minus 1 plus j, and then we'll have for int k is equal to j plus 1, k is less than nums dot length plus k. Okay, and we will check if nums of I is less than nums of k and nums of k is less than nums of j. If this is true, then we'll return true. Otherwise, in all cases, we'll return false. That's it. So let's run this. Perfect. We'll submit it. So see, this is three nested loop, and this three nested loop means that this is big O of n to the power n cube is the time complexity of this, because there are three nested loops in this problem. So it is natural that we will since the length is 2 to the 10 to the power 5, so it is 10 to the power 15, and in no way we are going to get you know this solution is going to succeed, because it will obviously it is going to have the time complexity of 10 to the power 15. Let's check it out. As was expected, we are getting this. So this is the block that we are hitting. So can we do something you know which will solve this problem? So can we do something like this? For int j is equal to 1, j is less than nums dot length minus 1 plus j. Okay. Int j is equal to 0. So right now I'll write int j is equal to nums of I. Okay. Let's write int right is equal to no 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 ये मत करो यार. Let it be like this. So we will write j is equal, j is 1, so mid is equal to nums of j, and right is equal to j plus 1, while right is less than nums dot length. We will get inside, and for int I is equal to j minus 1, I is less than j, I is greater than, I is greater than equal to 0, minus 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 I, and again we are checking if nums of j we have used here, mid is this, right is j plus 1, and then we are doing right plus plus. Okay, nums of I is less than, nums is less than mid, no, is less than nums of right, and nums of right is less than mid. So this is how we are getting the peak. If you are getting the peak, then we are returning it. Otherwise, we'll return false. So this is also three nested loop. So we have not, bypassed this logic. Let's see what's happening. So this is also running fine. Let's again we are getting TLE, same. So we are not able to bypass this, upper bound of, this big O of n cube. So now this approach is not wrong, but we have to, use some data structures and pre-process this thing so that, we are able to figure out, this um, in a with much shorter calculations. So one thing is there that if we have what is the minimum value till now at each and every point, so you see we are finding nums of I and nums of right. Okay, so if you are finding that minimum value at each and every point, then this is going to help. So let's, do it. So let me, delete all these things. Let me create one, int array min till now is this new int array nums of length min till now of 0 is equal to nums of 0, and then for int I is equal to 1, I less than min are the same thing, nums of length plus plus I min till now of I is equal to math.min 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 min till now so nums min till now I minus 1 nums of I. So like this we are going. And after this, what we are going to do, that we'll be creating one stack of the integer, and a stack is equal to new stack for int I is int j is equal to nums of length minus 1, j is greater than equal to 0, minus minus j. So first of all, we have to that if nums of j is greater than min till now of j. Okay, so if it is greater than, then only this nums of j is creating a peak. Okay, if it is greater than, then we'll check if while if first of all we'll check, if so this is greater than, then stack is empty. The stack should not be empty. If stack is not empty, then at the top the peak element, the stack dot peak is less than stack. The peak is less than nums of stack peak is less than nums of j. Then we'll be returning true. Okay. Okay. So nums of j is greater than min till now of j. So for the index j, the minimum value till that index j is smaller than nums of j, and the peak element is also smaller than nums of j. But to ensure that it is not, so we'll have to do one more thing. While stack dot is empty, the stack is not empty, and then we'll have to do while stack is not empty, and then stack dot peak is less than equal to min till now of j. Then we'll have to do stack dot pop. Okay, if all this is not happening, I mean to say, if we have, if if the element is not the following that 1 2 1 3 2 pattern, or if it is not required to be popped up, then we are going to save this in the stack. Why? So that we can use this for the next iteration. So this is the logic that we have to do. So let us run this. Are we able to fix this? Min till now, mine till now, my goodness. Perfect. Perfect. Let me know if you have any doubt. I'll try to answer those doubts with this. Thank you. Thanks a lot for watching this video.